Okay, so I guess we could start. It's 20 past, so I have an announcement. I was uploading files for the lecture that didn't take place last week. There was a holiday, and I was actually uploading slides for you, except it was stalling. I was already away for a weekend. It was stalling. I thought it would save the slides, but when I was uploading today's slides, I realized that it was not saved. So you didn't get slides from last week, which means and these were slides for the exercise on exercise 2, assignment 2, actually. So what I will do is I will negotiate an extension for you, so that you get the slides that corresponds to that material. Has anybody already done these exercises, or okay, so you must have had the background, or yeah. But for those of you who are not able to do the exercises because the last assignment, because the slides didn't upload for that material. Still working, but supplement. Yeah, exactly. So that's what I'll do. I will ask with the class guys to give you some more time, and I'll upload those slides today. So sorry about that. My internet was stalling, and basically I didn't wait till it came back with the site, but it usually saves it, so I forgot to check. That's my fault. It's entirely my fault. So there is a placeholder for this now. What's there is a text file. I will upload I have the slides on my proper computer, on my home computer. I will upload them as soon as I get home. The slides for today, another note is just a comment. The slides for today are also already uploaded, but you will notice that these are the same slides as for meeting on the 29th of April. We are basically just continuing the same introduction. We already talked about pre-processing and text representation, which is also in these slides. The text pre-processing is already in the previous slides. So this is the same deck of slides. I uploaded them twice, but just so that you have a record of what was covered when. And we are continuing today with words. Basically today is going to be mainly language-oriented with some technical content on stemming, but mainly linguistic content. So I guess we could start. Are there any questions from the previous sessions or any questions in general? Okay. Okay, so if there are no questions, I will just continue. I will switch off the video because, yeah, it's kind of weird to talk to myself. I see myself basically talking to myself. Okay, so today we are going to talk about words and word-related analysis and word-related linguistic phenomena, which are subject to linguistic processing in NLP or subject to linguistic investigation using computational methods. There are two levels to word analysis. One is the linguistic level that goes below words, so looks at what words are composed of. And the other level looks at words as such, as entities. And we are going to mainly talk about word classes today. Words have specific functions, grammatical functions, and play specific roles in a sentence, syntactic roles. We're going to talk about word classes, and these are specific to isolated words, but also to compound words. We're going to mention this a little bit. But we are not going to go to anything beyond this level. So today we are looking at phenomena up to word level, but not beyond. Beyond words, there would be, of course, phrases and then clauses and then sentences. Okay, so let's look at what is it that words consist of. Words are formed of smaller parts, smaller linguistic entities, and the area of linguistics that studies composition of words is morphology. Morphology basically looks at the individual sub-elements of lexemes. There are different morphological processes that words undergo, and different in terms of word formation, but also just phonological processes related to how words would be optimally pronounced. So they are not really related to the fact that word formation requires some only processes that add meaningful information to words. There will be also processes that add or modify parts of words for the purpose of, for instance, phonological harmony, for the purpose of, in simple words, ease of pronunciation. So one example of such a process, an inflectional process, is illustrated here with the formation of a past tense. We have a word call here, and the word call in English in the past is looks like this. It consists of this what we will later call stem or root, which carries the main meaning of the word, in this case of calling, and it obtained this inflectional affix, ed, that denotes past tense. So our past tense form of the word call is called, which consists of two elements. Now, a word that describes this state, the state namely of not being in a happy state, can be expressed using a word unhappiness. And you can see here how words can be formed from other words using derivation, in this case, derivational processing. And again, the core meaning of the word is in the root form of this word. We are expressing something about the state of being happy. So the root form in the base case is happy. In this case, you see already that there is a process related to word formation that takes this Y and in orthography, in spelling, turns it into I, which also has an effect on pronunciation. Instead of short it becomes happiness. It obtains an affix, which in this case denotes a nominalization of this verb, of this adjective here, happy. So it's a formation of a noun. We want to express a state given a property, which is denoted by this adjective happy. And this state we want to express is the negation of the meaning of the adjective. So for that, we can use a prefix in this case, another affix preceding the core part of the word in this case, and negation can be expressed in many ways. In this case, it's expressed by this prefix on. So altogether, we have an unhappiness, which consists of the core meaning carried by the root, the prefix carrying the negation, and the affix, which has a grammatical function of turning the adjective into a noun. Yes. So this is the illustration of this more complex problem of building a noun out of an adjective. You have these components of the nominalized form indicated here. This is a prefix and this is a suffix. Both of these are affixes. So affixes are in general any parts which can be attached, so affixed to an existing base form. All of these will be called morphemes. And morpheme is this basic unit that the study of word formation is using. This is usually described, this is not a perfect definition, but it can be more or less considered accurate, that morpheme is a minimal unit of meaning. So it's that minimal part that carries some meaning. So what is the meaning that is carried by the morphemes here? I told you about it. An expresses the meaning of negation. Happy expresses the state of happiness, being happy. Ness expresses the state of being expresses a state, basically, as opposed to an action. So some of them have semantic meaning proper function, and some of them have grammar formation function. So there is a distinction between free morphemes and bounded morphemes. We don't need to go into detail here. You're welcome to look at more detail under this link. Free morphemes basically are the ones that can be used as words by themselves. So here, a free morpheme will be the morpheme happy. An cannot be used as a word on its own, and ness cannot be used as a word on its own, of its own. And those morphemes that cannot be used in isolation as words in their own right will be called bounded morphemes. They have to be attached to something to add meaning, basically import their meaning to the free morpheme. The linguistic terminology about different types of morphemes and the composition of the morphemes, especially the in case of derivation, you might find differs between linguistic theories, even between course books. There is a different, sometimes there are different use of the word root and the word stem. Sometimes they are used interchangeably. We could say, for the purpose of this lecture, I will adopt a specific terminology where a root will be used to denote a single morpheme, which consists, which is not further decomposable. Whereas stem will be a morpheme which can be further decomposed, except stem will not include affixes of grammatical function. So root, as you can see here, is a derivational base. You create other words or other words from the root. And the stem is the inflectional base. So you can add other affixes, for instance, to inflect the word in case of inflectable word types, or you can create a word of a different grammatical function, as is the case here. So here, our root would be marked with the purple color here, hap. This pi, this element, is not part of the root because the functions of this second p is actually something we will not go into detail, but there is also a historic reduplication phenomenon that accounts for this double consonant here. I already mentioned that there is a phonological process that changes the Y into I. But the core, the further non-decomposable element of this base is this root that consists of the three letters HAP. The stem is everything that can be further decomposed except those morphemes that account for inflection or grammatical functions. So the stem here is marked with in this dotted rectangle. The stem, actually, if you see what it expresses a semantic meaning that is the negation of the root, right? We wanted the state of being not happy. So this semantic part, the stem will express the semantic part, is marked here in a dotted rectangle, it's unhappy. And the bounded morpheme nest takes the stem and makes it into a noun. Just so that you more or less know what we expect you to remember from this, you should remember what a stem is. You should be able to indicate a stem in a word. If it's a complex word, I would not expect you to know what kind of processes account, unless you're a linguist, maybe you know, what kind of processes account for this P and I here within the stem. But for simple words such as cold, you should be able to indicate the root, the stem, the affixes, and for instance, for a word that is a derivational variant of the word cold, recalled, you should also be able to indicate, for instance, the affix and the suffix and say what the functions is. Are there questions about this? If there are no questions, because we can just move on. So the main task of morphological analysis is basically identification of the word's morphemes. So decomposing the words into subword elements, linguistic elements, and identifying their role. This role may be of semantic or grammatical nature. There is a process in NLP that you may have heard of called stemming. This stemming, if you recall from the lecture on pre-processing, stemming was a standard part of a pre-processing pipeline. And stemming in NLP is used in a more practical or pragmatic sense. So often we will not build NLP tools to perform stemming in a linguistic sense, so identifying the stems, but as some kind of approximation of a stem of the word. Proper morphological analysis, of course, in NLP can be also done. There are methods for instance, finite state methods for performing morphological analysis, so identifying all the elements, subword elements in a word, but we will not look into detail there. So the stemming in NLP or stemming proper in linguistics would be identifying in a word its stem and separating it from the inflectional affixes. I'm talking about affixes here because for English, these affixes will be, for the most part, suffixes, inflectional suffixes, but there are languages in which both suffixes and prefixes are equally represented in terms of building inflectional forms. So I think I missed saying it explicitly, but a suffix is a type of affix that attaches at the end, and the prefix that is a kind of affix that attaches before the word. So that precedes basically the element. What kind of inflections are there? So what kind of inflectional affixes might be removed? In case of nouns, this would be declination. In languages, in inflected languages, this inflection might be quite complex, might include grammatical case, number, gender, and so on. English in this respect is rather let's say poor inflectionally, but German already is not. In case of verbs, we have conjugations, so inflection by person, number, tense, mode, and so on aspect. The verbal system, inflectional system can be quite complex in some languages. For instance, Slavic languages or Latin languages in general. And adjective and adverb comparison. So there are comparative affixes also that indicate the comparative and superlative forms. Here is an example of different word formations stemming from the word connect that denote different word forms and different word types. We will get to that, to the word classes. Connects, by adding the suffix s, we obtain a third person form of the verb connect. Connected, with the suffix ed, we obtain the past tense. Connecting, the continuous tense, and the shin, in this case, with omitted the double t, we obtain the nominalization of the verb connect. Computational approaches to stemming have rather long history. This is one of the most basic processing types, pre-processing types that have been attempted in using computational methods. The methods range from simple, basically database lookups of words that are stored in a form of a dictionary. So a word stem is stored and all its inflections installed are saved in stored, for instance, in the form of a hash table. This resembles very much what you might know from language learning. In inflectional languages, you will see these kind of conjugation and declination tables for nouns, verbs, and this is basically what this approach is corresponds to. Of course, the problem with such an approach is that it's rather hard to encode all the possible words, so the completeness is a problem. There is no generalization. There's only what's encoded in the data and stored in a database. There are rule-based algorithms that identify prefixes and suffixes, so the affixes. They are based purely on a surface form of affixes. So you store information about what types of endings and prefixes exist in a given language, and assume that if we cut off that part that in a surface form corresponds to what we stored as affix, would result in the stem of the word. This is a method that is still very often used. This method is known as affix elimination. This method is, of course, error prone. You already see here, if we assume that there can be an ending s, this ending in English would account for both third person verb and as well as plural, but would of course, cut off all the s's from words that genuinely end with s, not being a plural, right? So it's error prone, but it's an easy and intuitive method. Still more robust and less linguistically informed is a method based on character engrams. So remember that an engram is an entity that consists of n smaller entities, where the n is the order of the engram. In this case, as the base unit, we would take characters, letters, and most methods are based on 4 letters or 5 letters that are removed from the words, from the token, and the rest is assumed to be the stem. As you can see, this method is not at all linguistically informed. This is it's a completely arbitrary decision to use, for instance, 4 characters to be the first 4 characters to be the stem, or 5. It's equally arbitrary. For long words, of course, this will not work, but in many applications, this method is sufficient. Of course, this results in tokens that do not have any linguistic meaning. They are not valid linguistic entities in many cases. So if you just take the first 4 letters of the word, for instance, structural or linguistics, the 4th characters would be ling. This is not a linguistic unit. For 5, even worse, lingu, this method results in non-words, but often, ironically, in a robust NLP system, this is sufficient. And finally, the methods that would be, let's say, most desired by linguists would be a method that is most linguistically informed, that exploits the structural properties of a word and identifies morpheme boundaries, so identifies which element of the word, where the boundaries between the sub-elements of the word are. This is, of course, such methods exist and are usually explored in morphological analysis proper. Of course, it's difficult to operationalize, requires a lot of encoding of linguistic knowledge, and it's mainly used in morphological analysis proper, as stemming more often than not, the more robust methods are used, even if they are not at all linguistically informed. There are several examples of stemming approaches to stemming in this deck of slides. I will show you, just briefly talk about the general idea of some of them, and I will ask you to go through the details at home. So this method of affix elimination, the main principle of implementing this method relies on consecutive longest string matching. So the method relies on a set of rules that encode candidate affixes. And the idea is basically to match with the given word the longest affix, the affix that match the rule that represents the longest affix. There are some irregularities that can be captured by the rules, but not all irregularities are easily encodable by simple static rules. So this method is this process, of course, proceeds in multiple repetitions. You try all the rules until no further rule can be applied. The intuition is rather simple. This method works in many cases, but not in all. It doesn't work, of course, in a lot of irregular inflections or in irregular derivations, but it's a robust method. This is the example of an encoding, and the details you're welcome to check at home. So this shows rules for English. Basically, you encode vowels separately and consonants separately, and there are rules for the current substring that ends on a vowel or consonant. one of the most frequently used stemmer is the Porter stemmer. This is a rule-based stemmer. It's still very successful, and like I said, one of the most widely used stemmers even today, even though its principle is quite simple. Of course, nowadays there are also deep learning-based morphological analyzers and stemmers. But the Porter stemmer is fast and it's quite simple. It operates on a set of rules, rule sets actually, which each of those sets consists of several rules grouped according to principles, what they are, what their function is in relation to a given cases of affixes. And these rules are sorted and applied in order. You'll see a formal definition of a rule here, and I'll ask you to look at the details at home, and you can ask questions next time. Here are examples of rules. You'll see that each rule will have a premise and a suffix and a replacement. So for instance, in this case, in case of a suffix of this form, this suffix will be replaced with this form. An example is here, caresses. These suffix as specified by the rule will be replaced by what is in the consequent of the rule. Here's another example. This kind of suffix will be replaced by this. Ponies will lead to pony. And so on. Just look at those rules, and if you have questions, try to analyze that it holds, and if you have questions, we will look at them. We will answer questions next time. Here is an example of the kinds of analysis that Porter stem is capable of doing. It's actually robust, it's fairly accurate, and that's why its popularity is so wide. You see here that some endings, some affixes, some analysis is performed correctly, but some is not. Here is an example of an incorrect analysis. Of course, Alan Matheson Turing is not a continuous verb, and this ing is incorrectly identified here. Was is an irregular form of the word be. In this case, the Porter stem would remove the s because it thinks this is either a plural or a third person verb ending, and so on. So some of those rules will result in incorrect analysis. Highly here, with linguistic knowledge, we know that highly was formed from an adjective high by turning it into an adverb by adding an adverbial affix ly, le. And in this case, Porter stem would make a mistake and chop off only the y. So unfortunately, fortunately or unfortunately, as you prefer, stemming performed even in this inaccurate manner often doesn't hurt performance of the overall NLP system, especially if the system is not geared toward detailed semantic, for instance, analysis or discourse analysis. In case of, for instance, topic models, this kind of analysis would be perfectly sufficient. Okay. I already mentioned some of the weaknesses of this algorithm, the rules, and because this rule set is rather large, there are sets of rules. If you change one rule, it's, as with any rule-based system, it's hard to predict what the effect it will have on the remaining rules because the rules are applied in order. We already saw that it overgeneralizes. Here are two other examples of overgeneralization. And it doesn't capture generalizations, of course, at all. It's not, the rules don't encode generalizations for the most part. So this results in these kinds of errors. Especially in irregular word formation. This is not something that a rule-based system is capable of doing easily, or these kinds of regularities. Not all regularities are easily implementable in a rule-based system. Another type of stemmer, an approach to stemming, combines basically these two approaches, the dictionary-based approach and the rules. So there are two resources. A word is first looked up in a dictionary. If it's found in a dictionary, then the dictionary analysis is taken as the analysis. If it's not present in the dictionary, then the rules for removable affixes are applied. And after the application of those rules, the dictionary is checked again. And if it's still not found in the dictionary, because by then the dictionary, the base form, after removing those affixes in this previous step, the base form should be obtained. If this base form is not found in the dictionary, then a different suffix is tried. So it's a combination of both. It's more robust to capturing irregularities, such as inflection of irregular verbs. And it produces actual words, not these weird stem-like or even non-linguistic stems, because we are checking the resulting base forms with a dictionary. So it will produce linguistically meaningful entities. In terms of effectiveness, is comparable to Porter's stemmer. It has a lower false positive rate because we are always checking with a valid resource, that dictionary. Of course, the problem is that this dictionary is maybe incomplete. So the usual problem of completeness is present also here. Here's an example of what a Porter stemmer versus a Crowett stemmer would do. The Crowett stemmer still doesn't know that Turing is not a word, a verb, and it's a proper name. It still doesn't know about these endings, some of the endings of complex words. But as you can see, the performance in terms of validity of the result, correctness of the result is much higher than that of the Porter stemmer. And of course, valid words are preserved. So theoretical as opposed to theoretic, theoret, which is not even a word or stem or anything. Okay, the last example of the least linguistically informed kind of stemmer is based on character engrams. Basically, the stemmer based on this approach tries to identify a stem to be a substring of a given word of some length. So in case of unigrams, these would be individual letters. In case of bigrams, it would be two letters, combinations of two letters. Trigrams, it would be combinations of three letters, and so on. And basically, this stemmer says, okay, everything I've identified as the first n, in this case 4 or 5 forms of a word will be the stem. Sometimes it's referred to as pseudostem. Of course, it's not stem in any linguistic sense. But like I said, unfortunately or fortunately, in many applications with large data, this works perfectly well and is also very often used. The good thing about this approach is that it's language independent. Of course, the N for each individual language has to be set individually. It's very robust, it's fast. For some languages, the performance using these kinds of linguistically uninformed stemmers is very good. For others, especially for heavily inflected languages or agglutinating languages such as Turkish or Finnish, the performance would be much worse. Okay. The Stemming is this most basic type of analysis, which results in um, entities that are not really words, in some cases not proper linguistic entities. It introduces some artificial entities into the analyzed data. And the problem is that for applications where linguistic information is important, this is of course not acceptable. So instead, a different process called lemmatization, so identifying linguistically informed base of a word, the lemma, or in other cases it's called root, um, um, would be employed. And in this case, the analysis and the computational approaches are much more linguistically informed. Typically, these are based on dictionaries. There is some dictionary lookup to verify the validity of the obtained forms. The same holds of morphological analysis proper. So lemmatization is this process of obtaining now the linguistically valid lemmas of the word, and derivational morphology would also try to identify where the given what's the origin of the given word. For instance, in the case of nominalizations, it would try to identify the original word form from which the nominalization was obtained. For instance, the verb or the adjective from which the noun was formed. Okay, here's an example of now coming back to pre-processing. We talked already about this initial cases of initial steps of pre-processing, where we typically will lowercase all the words, remove punctuation, remove stop words. We talked about stop words, and then perform stemming. So from the original text given here, we obtain for further analysis in an NLP pipeline this kind of not linguistically informed fragmented string of entities for further analysis. Of course, this also only holds in the case in the case where preserving syntactic structure and preserving sentences is not relevant. So not all applications will admit of this kind of linguistically uninformed analysis. Okay. So we talked about what's below words, what words consist of. Sorry, my voice is again starting to, it seems to be a pattern that after an hour my voice starts misbehaving. Okay, so we looked at what is below words, so what words consist of, and now let's look at words themselves. And the main observation about words as such on their own is that they belong to different classes. And these classes are related to the function that the words take in a sentence. So in linguistic, a word class is a group or a set of words which behave the same way grammatically. So you could say more formally the same formal display the same formal properties, especially in terms of the inflection and distribution. So this distributional property, distribution corresponds to grammatical functions. So they appear in certain, for instance, position in a sentence. There is also alternative terminology, which is more frequently adopted in NLP, and word classes are very often called parts of speech. Parts of speech is actually the historic term. They don't mean the same exactly, word class and part of speech, but we can safely skip the finite, if I fine distinctions. They are sometimes called grammatical categories, lexical categories, syntactic categories. We don't have to go into details between those, but in linguistics there is a distinction in between what you mean by part of speech and word class. The major two word classes are lexical words, so words that form that are have a semantic function of their own. So lexical classes are those classes that are open and have in principle an infinite set of lexemes. Those are nouns. You can create nouns in arbitrary ways. You can create new nouns. The same with verbs. The same with adjectives. The same with adverbs. So these are called open classes because the formation processes and actually forming new words in these classes is in principle infinite. The other class is the class of function words, also known as closed class words or structural classes. And these are those, you could say, you could also hear them referred to as small words, so-called small words. These are determinals, particles, prepositions, and others. Those words that have a purely grammatical function. And this class is called a closed class because no further words will be added to this class. So we don't come up with, in English, suddenly with new determiners. We don't come up with new particles, whereas we do come up with new nouns and new verbs. So these are the main two classes. One is an open class of verbs that have semantic function in a sentence, and the other has, of course, does have a semantic function, but has a main grammatical function. Let's look at the open class versus closed class distinction in more detail. Open class words, in principle, like I said, have infinitely many members per class. And here are their definitions. So what is a noun? This is, I guess, for most of you, should be obvious. A noun is a word that is used to name some person or thing. There are some caveats to each of those classes because different linguistic theories, again, look at the different word classes or parts of speech in a different way. So, for instance, some make a distinction between references to places and abstract qualities, for instance, or actions. So this is, you will see that in a part of speech approaches to NLP, these distinctions will be visible in different so-called parts of speech tags assigned to entities of different types. Adjectives are words used to qualify a noun in a way or restrict an application of a noun, restrict the meaning of a noun by adding something to this noun's meaning. Examples are obvious for adjectives, I hope. Again, the comment here says, well, this definition is very broad and it is vague. For instance, you could ask, well, if it's qualifying a noun or if it's restricting by adding some meaning to the noun, maybe my is also an adjective. Well, how about the? The restricts the application of a noun that adds the meaning to the noun that says, oh, well, that's this specific thing as opposed to any other thing. And indeed, some approaches to word classes, some linguistic approaches do consider pronouns, possessive pronouns such as my as adjectives, and it's not an error in functionally what this adjective does in terms of grammar is has a function of an adjective. A verb. Verb, again, it seems like there's no problem with verbs. Verbs are used to say um, something about another a person or a thing. Typically denotes an action. Uh, but again, there is a problem with verbs because, well, if it says something about some person or thing, in this case, if we say it's only an action, then it's fine. But if it just says something about person or thing, then it doesn't look much different from an adjective. So again, the emphasis in case of verbs in most grammars is on actions. So the verbs will typically denote actions, but there are grammars that like considering verbs on a par with adjectives and don't see much difference between them. In terms of formal modeling, in fact, in formal linguistics, in some approaches, the formal expression of a verb, so a mathematical expression for a verb and adjective, would be very much the same. An adverb is a word used to qualify any part of speech except a noun or a pronoun. So very often, that now adverbs modify a verb. So you can, for instance, walk slowly, or they can modify a whole sentence. Today, something happened. So typically, as is noted here in the comment, adverbs are used to qualify those entities that qualify verbs. This is inadequate, of course, because they can also modify other grammatical entities. The closed class words, of which the number is finite, and it rarely happens at this point where with the languages that are of core interest in linguistics, and pretty much with most languages at this point, there are rarely changes happening to the grammatical system that would change the set of closed class words. Those are to some extent closer to being more rigorously or better, more clearly defined. So an example of a closed class word is a pronoun. A pronoun is a word that is used as proxy for a noun or something that is equivalent to a noun. Examples of pronouns are he, she. Every language pretty much has pronouns. There are pronouns of different types. Demonstrative pronoun this, for instance, may refer to some object, but this may also refer to a proposition. This happened 5 years ago, for instance. Peter sold his car. This happened 5 years ago. So this can also refer to propositions. So this definition is almost there, except, yeah, if we just say that pronouns refer to nouns, this is inaccurate because we have those cases of pronouns referring to the propositions. But it's closer. It's closer to it being more clearly defined, and it's easier to enumerate all the cases. Prepositions are words placed before a noun or a noun equivalent to show a relation within which this noun, this person or thing stands to something else. Examples of prepositions are such as on, to, about, over, and so on. This definition is based on a syntactic criterion, pretty much. And we can say that pretty much prepositions usually stand, in case of English, before the noun. There is some clear-cut grammatical criteria based on which you can identify them, and you can say that there are rather reliable regularities in English, for instance, about how prepositions are placed. So prepositions, let's say, I would say, are closest to being most clearly defined. Conjunctions are words used to join words or phrases together. These may be nouns, these may be clauses or sentences. Examples of conjunctions are and, before, as well as, to, and so on, or, but. Conjunctions, of course, are of different types. And or are coordinating conjunctions. Before are is a subordinating conjunction, and a temporal that introduces a temporal or sequential aspect. So the main point about conjunction, as the word itself suggests, it conjoins things, is there. But you can observe that in fact, yeah, prepositions kind of have a similar function. So if you say that a preposition puts one person or thing in relation to another, like the example here, the man in the garden, you could say, well, it also somehow joins these two things, the man in the garden. So again, this definition is the wording used in the definitions is almost there, but not quite there. Of course, the problem with defining linguistic entities using language is that you're using the same, there's no meta language to talk about them. So you have to use words that you're trying to describe at some point. Interjection is a is an interesting class of words that is denotes some feeling or some paralinguistic information that carries some paralinguistic information. Examples here are "oh" or "bravo." So this can be thrown into a sentence. It doesn't form a sentence of its own, even though it stands on its own. So typically these interjections form so-called sentence fragments, but are pretty much in all cases analyzed as sentences. As valid sentences. The key point about the interjection actually makes them probably one of the best defined classes. The problem is, though, that they do not enter into sentence construction. So typically they look like sentences, they are not sentences, and they are not analyzed together with sentences. For the purpose of NLP, often they would be also analyzed the same way as I just mentioned, as individual sentences, rather than in connection with the sentences to which they add emotional content, or the discourse to which they add additional content, emotional content. So yeah, so these are word classes, and I already mentioned problems with the definition. There is, of course, another problem with word classes, and that is that most of word forms are ambiguous. They may belong to more than one word class. And in English, this is very often the case. Here are some examples of ambiguous words. The word back in the sentence, the back door, has a function of an adjective. On my back, here the word back is a noun. When the voters back, win back, now it's an adverb, it modifies the verb. And he said to back the bill. Back is here used as a verb. So the same word can belong to multiple classes. And the identification of the class of a given instance of a word is very often facilitated and always facilitated and very often clearly determined by context. This is an interesting note. There was another note from an Oxford Dictionary of English about word classes that I would like you to read and think about at home, and just think about what you're dealing with, what type of entity, what kind of issues you're dealing with language in fact, when you're doing NLP, and very often you don't think about it, what kind of complex problems there are um, in the text that you're analyzing, that typically, very often at least, is analyzed in NLP at a very shallow fashion. But it's good to be aware of this, of the issues. And of course, there is an NLP task that consists in identifying the word class of a word, to which word class a given word belongs. In NLP, it's very often referred to as part of speech tagging. Like I said, more often than not in NLP, the term part of speech is used. So this process is a process of assigning a word class, part of speech, to a predefined from a predefined set to a word. Here is an example of a sentence: the dwarfs loved her dearly, and we have a morphological analysis here and below, and a phonetic analysis. We will not go into detail, but each of those words have been assigned part of speech, some part of speech. In this case, these are classical word classes. So dearly is an adjective, her is a pronoun, loved is a verb, dwarfs is a noun, and the is a determiner. Now, the main issue or the main question in NLP that you have to ask yourself when doing assignment of word classes is, well, what set of word classes to use? What I showed you earlier are the so-called standard classic or most frequently used classes in linguistics and in grammar, basically. The 9 parts of speech: nouns, pronouns, verbs, adjectives, adverbs, prepositions, conjunctions, interjections, and determiners. And for most applications, these broad classes are sufficient. In fact, these are the classes that are used by modern NLP systems under the heading of universal parts of speech. This is nothing else than the traditional word classes known to grammarians forever and reinvented not so long ago by NLP people. But there are other sets of parts of speech that are equally frequently used. Some, the range of classes that they include maybe from anything like 30 classes to about over hundreds and almost 200 classes for some cases. Here is an example of the kinds of sets of word classes that are most often used in NLP. In NLP, the set of classes that you'll be assigning to from which you'll be assigning a class to a word or part of speech to a word is very often, is always, I would say, referred to as a tag set. Sometimes it's spelled together, sometimes it's spelled separately. So a tag set will be a set of classes from which you'll be assigning one of them, one to each of the words in a sentence. And the most frequently used tag set is a tag set stemming from the Penn-Treebank project. The Penn-Treebank project built one of the first and largest at the time corpora of syntactic analysis of sentences. And the syntactic analysis, of course, includes also analysis of every word in terms of its part of speech. This tag set consists of 36 tags. There are other tag sets developed in equally, I would say, influential projects, and one of them is the clause tag sets stemming from the UK, from Lancaster. And there are various incarnations of these tag sets, and the set of classes it includes also ranges. The first version had 132 classes, the second version had 166 classes, clause 5 has 60, clause 6 has 160 again, and the current clause version 8 will be a homework. You will be asked to look at this tag set. Like I said, the universal pause tags are mainly for the most part based on the classic parts of speech. It includes 17 tags that have been designed to cover or account for most languages. That's why it's called universal pause tags, because it covers most classes of the present in most languages. So here are the word classes, open word classes from the universal tag set. You see, we already saw all of them: adjective, adverb, interjection, noun, proper noun, and a verb. So this is the difference here. The proper noun is distinct from a noun. Close class words are also distinguished some specific categories. There is a category for adposition. We won't go into detail. Auxiliaries, auxiliary verb, conjunction, coordinating conjunction specifically, determiner, numeral, particle, pronoun, and a subordinating conjunction. So there is a distinction made between subordinating versus coordinating conjunctions. And others, in this case, it's punctuation, symbol, and waste basket category, other, for anything that is none of the previously mentioned. Here is the pantry bank tax set. So this tax set had 17 categories. It looks nice and friendly. Very often you will see, when you work in your projects, you will see pantry bank tax set. This is a very frequently used tax set that distinguishes some meaningful subcategories of some classes. So for instance, here there is a distinction between adjectives in comparative, in base form, comparative, and in superlative form. It distinguishes modal verbs from other verbs. For nouns, it distinguishes between singular, plural, proper in singular, and proper in plural. So 4 categories for nouns. There is a category for the possessive ending, so just the Saxon genitive, the apostrophe s. There is a distinction between different types of pronouns. So here is a pronoun, personal pronoun, possessive pronoun. Adverbs, just like adjective, are distinguished in terms of base, comparative, and superlative forms. And there are several forms of verbs. Verb in a base form, verb in a past tense, verb in a gerund or a present participle, verb in a past participle, so distinction between participle versus inflected tense formation. So participle can be also used in a function of an adjective, so verb in a form of a participle. Yeah, like a broken glass. This would be then in the pantry bag tagged and VBN. But if you want to identify noun phrases, you have to know that nouns can be modified by participles. So you'd have to identify this tag if the corpus you're working with is tagged with pantry bank. Then singular present, non-third person, and third person singular present. So you can see there are several classes for verbs plus modal verbs on its own. And there are different types of pronouns and determiners, and specifically WH pronouns and determiners have their own categories. So here is a WH determiner, which WH pronoun, possessive WH pronoun, whose, yeah, and so on. And I would like you to take a look at the clause tag set, clause 8 specifically. This is what I already mentioned earlier. This tag set has 170 tags. So look at at home, look at the clause 8 tag set, and look at the pantry bank tag set, and look at the universal tag set, and think about what you can get. So what's the motivation for using one or the other? Why would you, in what applications, try to think about in what applications would you use one and not the other, and think in terms, and we can discuss it in the beginning of the next session. Here's an example of a part of speech tagging output. So the part of speech tagger would take a plain text here and identify each of the parts of speech for every word. So here is the Pantry Bank tag set, and um, in this case, it's the output stems from the Brill tagger. I will talk about it in a moment. And every word is tagged according to its word class part of speech. And this format with a slash is something that is also very often used. Another format is a format in which every word is on a separate line and the part of speech is separated from that word with a tab. So when you work on your systems, you have to account for reading part of speech tagged inputs, and you have to know what the format of that input is. So part of speech tagging is then the task, NLP task, that corresponds to identifying the part of speech of every word. How is it done? Well, as we already said, you know a word by the company, in this case, syntactic company that it keeps. So you look at the context in which the given word occurs. There's also, of course, other information that you might use to disambiguate which part of speech, in case of ambiguous words, is the one that is intended in a given instance. But very often the analysis is done. So for instance, semantic information or shallow parsing also. But for the most part of speech tagging is also considered part of pre-processing and mainly contextual information on adjacent word of a given word is used to assign parts of speech. An early approach to part of speech tag, and tagging one of the first, I guess, was introduced by Brill, early 90s. And this tagger is based on a set of rules which assign the most likely tag to a given word. And in multiple iterations, it transforms the output to correct the possible errors, applies rules in an iterative fashion, and tries to correct the previously assigned tags based on context and based on what the most likely sequence is at a given point. I will not go into detail here, but there are rules of a specific form in Brill tag. I will ask you to look at this at home, and we'll discuss it next time. Actually, conceptually, this is a rather simple approach. This is why we are talking about it here in the lecture. Modern approaches to part of speech tagging use machine learning, and for the most part, I think it's still sequence learning that is most robust and performs best in the task of part of speech tagging. And those approaches are currently state of the art. However, this transformation-based approach is still, as a conceptual approach, which can then be used in many other contexts, worth knowing as a rule-based approach. Okay, so you have some homework to do. This concludes today's, I think, yes, this concludes today's lecture. Are there any questions?